Hello, my friends. I know you can't wait, and I get it. It's to wait a week for another video, and then it's not that what you want. That's why I'm celebrating 3,000 subscribers, and you are one of them, hopefully. And that's why I bring out two videos today. We move on directly into Honeybee Radiance. And before we start, a quick shout out to Sasad Islam. I hope I pronounce it correctly. Sasad Islam. He suggested I will use bifocals, a plugin to make it better readable on what I'm doing here on the screen. It will automatically label all the tools because I know that some of you are using the names. I like the symbols, and I think it's a really good way to do it. Thanks for the suggestion. Really appreciate suggestions like this, so we can all create a much better content. By the way, if you want to download this script, I just made it available on the last video's show notes. There's a link, you can download it. And please, you need to turn on all these run buttons when you start it. I also internalized the geometry, so you don't need to model anything. You just run it and see if then if it doesn't work, then you probably installed something wrong, I guess. Yeah. So Honeybee Radiance. Let's see. So this was my model, as you hopefully can remember. If you don't, please go back. The core tools of Honeybee are very important to understand before we move into any of the other items and analysis tools. So please, not just for my view count, but I often get questions where I think, yeah, I already covered that in the previous video. So please check it out. Honeybee Radiance. We will not cover everything, but we will create a simple analysis. So we will set some basic properties. Preview. That's a preview. Basic properties. We will not look yet in the modifiers. This needs a bit more explanation and needs a longer video. I try to keep this quite short. It's like a first look, first closer look into analysis. So we will do an annual daylight study. The others are very similar, and if you follow along, you understand what's happening here, then you probably also understand the others. We will look into light sources a bit, and that's pretty much it for this video. So let's keep it short and sweet. So, okay, here we just prepare basically the geometry. We set it up, these rooms. We solved all the adjacencies, as you can remember. Then we applied apertures. And then we also showed how you can modify or rotate your model and so on. And then we put everything in a Honeybee model and then visualized based on what we want to see. For example, we wanted to see the exterior walls and so on, interior floors and so on. And for now, I just turn this off. So if we want to run an annual daylight analysis, and we're not talking about modifiers yet. Modifiers basically set different materials, or for example behaviors of materials like glass, for example. Here these are the modifiers, basically glass, metal, mirror modifier, and so on. And there are modifier sets that basically helps to apply a set of modifiers to a room, so you don't need to set it individual. That's very helpful. But I think we need to spend more time on that in probably the next video. So we look at how to set up a very simple study. In the next video, we look more into detail on how that works. And then we can test more of these things here. So in order to do an annual daylight study, for example, and probably there are different ways to do it, we need to apply a sensor grid to rooms, for example. And there are two ways to do that. One is like a sensor grid where you basically create a surface and then apply the grid, or the other way, which I like in that case, because we already have the rooms, we can actually apply Honeybee sensor grid from rooms. That's very handy. So we can, for example, let's get all the rooms, and we apply this sensor grid from rooms tool. Now you can actually read it, and I don't need to say it anymore. It's really cool. And we need to set a grid size, because my model is in meter, and I suggest you do the same. We generate this grid over all the different rooms. So we have 4 different rooms, 1, 2, 3, 4, 2 on the level 1 and 2 on the lower level, and they all get a grid applied. But what we need to do now is we need to assign these grids to our model. So whenever we run a Radiance, whenever we want to run one of these studies, we need to assign the grid to the model. And we can do that with this tool. Add Radiance sensor grid and or views to a Honeybee model. So we get this tool here, and that shows you the mesh where that is. We actually don't need that. We need that later, actually, for the visualization. But here we just add the grid, and then we add this to the model. And now this is our new model. So we need to assign it, and then this is our new Honeybee model with a grid assigned. I want to organize this a bit different. So this is our model. Now, if we get this tool here, the Honeybee Annual Daylight, we see that we need a model, and we need a WEA object, a weather object. And there are different ones. So there you can see that these are based on sky models. There's like custom sky, climate-based sky, Honeybee CIE standard sky, and so on. Anyway, first we need the model, and then we need a weather file, data prepared for the annual daylight study. In that case, we can actually use the E+ weather data as a source, and we just plugged it in here. Now we need an E+ weather file, and we get it from Ladybug. So we just get the download weather. No, we need this one here. We need the E+ map, the E+ weather map. Boolean toggle, turn it on. Not now. Tunis. Let's go to Tunis. Download, copy link to clipboard. That's what I'm using. You can also download it. It's anyway the same. Because what it does here, it just stores it in a folder. But of course, if you have no internet access or no access to these files, then of course, and you get some other E+ weather data, then then you can use the folder instead. Now we have our E+ weather file from Tunis. In that case, you can plug it in here. And what else do we need? Because now, you see, if I don't apply the grid and I want to run that, and most people have this problem, it first works. Now let's run it, and now it doesn't work. And everybody's like, how does it work? And then they try to grid filter, should I apply the grid here or something? No, you need to apply the sensor grid here to the model. And then if you now put the model in here, then it starts to calculate. And now it's done. Now you can't see anything yet. I just still want to explain you something here. You can change also the distance. So you can change the distance to the floor of these grids. At the moment they are in a certain height. I think it's table height, which makes sense, but you can change that if you want. So you can change it, create a different height. I turn this off so we don't see that. And now we have all of these tools. They have a certain purpose. And I suggest that you read through, so you actually know what's the output. And here, for example, I will not go through everything, so you can read yourself, but I will read the first one. You can actually see what the output is. And you also get, this tool also writes files into your computer. And that's good to know, because if you ever run into the problem that your computer is just too full with stuff, then you should also check these things. You might have like huge amounts of data on your computer, and they're not, and they just occupy space on your computer. So you can from time to time check, and it basically creates the raw data in a file format which is ILL, containing illuminance matrices. So we will not go further into detail now, but for example here, what is the annual daylight? Daylight autonomy results in %. DA is the percentage of occupied hours that each sensor receives equal or more than the illuminance threshold. Each value is for a different sensor of the grid. These can be plugged into Ladybug spatial heat map along with meshes of the sensor grids to visualize the result. These can also be connected to the Honeybee spatial daylight autonomy component to compute spatial daylight autonomy for each grid. I guess you need to read it a few times. At least I need to do that to try to absorb, and then probably need to also Google some of these names and what does that really mean. But that's how you basically set up like a very basic annual daylight analysis, and then we can try the heat map. Let's do that together. We can actually set up the Ladybug spatial heat map. This is this one here, and we need values. We have values here, and we need the mesh. And now we need the mesh. So mesh is here. Yeah, so we plugged in the mesh. Now you can see that it didn't completely work out. The problem is that we have 4 rooms and we have 4 grids and 4 meshes, and it doesn't just understand why now there are actually. It's always good if this happens, if this is red and you don't know what's going on, you can click here and it actually tells you the problem. So the numbers of colors and the mesh faces and so on versus they don't fit together. So what's the problem? Well, if we would only have one room, then it wouldn't be an issue, because then it would work without problem. Now, because we have more rooms, I will give you a very quick. Well, first I give you a workaround, and in the next videos we can look on how we can make that more elegant. By the way, we can also retrieve the mesh, which is actually better. So if you go here, there's another tool called Honeybee Get Grids and Views. That's actually a better way to get all the meshes and points and grids from the model and not from here. That's also possible. It doesn't really matter really, but if I change the mesh here, it will recalculate everything. So I just disconnect this here. Now it also does that recalculation because it's going through the model, and whenever we change something in the input here, it will rerun. Now you can't see anything, of course, but if I basically get the meshes after the model, which then don't have an influence on the input here, then it doesn't rerun. That's very helpful. So now I can put the meshes in here and still red, and the reason is that first of all, it's now we have 4 meshes move in. It doesn't know which mesh to use, so we can first join the mesh into one, and we will look at other options. We can also select different meshes or different rooms actually instead, but in this case we just do it like this, and now we can put the mesh in here. It still doesn't work because now we have one mesh, but we have 3 lists of numbers of values, so that's why we need to actually flatten that list, so then we have all the values together. There are other ways to do that. We can actually select by room, and we can look at that next time. Yeah, see, worked. Just turn off the grid. Can't see much difference here. but we could, for example, now set a minimum and maximum with the legend parameters. So we could go in here, set parameters, and set a minimum and maximum. That's I think it's very useful. You should always do that, because the problem is if you compare two different scenarios, your colors will always adjust to the range of values. So for example, if you have values from 0 to 60, then 60 will be red, and in that case we can control that by setting this minimum and maximum, and then also it makes it more readable, right? So then we can play with the values to make it visually more readable. Just want to say we haven't set any specific schedules yet, and radiance parameters and so on. This will all come in next videos, and you can already see that there is a lot to cover, especially these modifiers. It's going to be really interesting. But yeah, so for example here for the apertures for the windows, you probably could set a glass modifier. Let's try that quickly and let's see how that influences the output. We can set the name. That's transparency and the refraction. The transparency, let's set the name first. Transparency, set the name between 0 and 1, a number between 0 and 1, and refraction. And yeah, we can also try that. Set this to 2, and that we can put in here into the radiation modifier, and then now of course it's recalculating. But yeah, so this is just a preview into the next video. Next video we will look much more in detail and what is a construction set, what is a schedule, or we could also first go through all these different recipes and then go more into detail. But I think in order to understand radiance, we need to cover this definitely. So I think it's better we start with the modifiers and then move forward into schedules and how to use the grid filter. That's basically selecting which room you want to test, and radiance parameters and so on. A lot of it is not mandatory here, but I think we need to really go into detail and really understand it. But yeah, I think, I guess some of you already know more than me in that case. Then feel free to experiment and test. And yeah, if you have suggestions or you think I missed something for now, then please let me know. But I think so. This is the basic understanding, the basic setup for a script. Just one more thing. Let's cover one more thing. The annual daylight calculates the whole year. You can also calculate just a month if you want. And that's done with the hours of the year. So Ladybug works in that case a bit different. The new Ladybug tools, they work a bit different than the previous one. The legacy tools, you could set a period. You can still do that, but in that case it's actually easier because you can just set the period before you go into the tool which actually calculates. In the past we always had like a tool in here, like for example for the annual daylight or for any other main analysis tool, there was then a place where you can provide a period, and that is now basically outsourced into a different tool, which is this one, analyze period. So you can set here the dates, when does it start and when does it end, and the end month, the start month and the end month, this is the day, and then the start and the end hour. And I need to explain something with this because, and you also can set the timestamp, the interval of now at the moment it's every hour basically. Anyway, what you need to remember is that if I set here, for example, May until June, and I set the start date is at 1st of May, and the end date, let's make it easier. The end date is end of May, and the start hour and end hour, that means it will calculate every day from the start hour to the end hour. If you want to calculate everything, including the night, which doesn't make much sense, then you set it to 0. But if you want to test a specific hour, then you could do it like this. You could set 7 and 8, and it basically gives you one. It's actually 2 hours. You can set it to 7, so you can basically test 1 hour per day, within this period. I hope it makes sense. And then you can feed this into here, and now it recalculates. And now you get the output for that specific hour within that period. And now we would probably need to adjust our minimum maximum. There's not much difference because it's always the same, I guess. So anyway, we will look into that more, but I hope that gives you like a first flavor on how Radiance works. Again, thanks for watching. Let me know if you have any questions, suggestions. Always welcome. It's always good to hear the experience from other people, and I learn so much. Please let me know, and see you in the next video.